So hi, I am Robert Love. I'm a software engineer at Google. I'm going to talk to you about Android, which is our mobile platform. All right, yeah. So to start, we're going to cover some basics. What is Android? What do I mean when I call it a platform? And what do I mean when I say it's going to be free and open? Android is a complete mobile platform, soup to nuts, from the lowest levels of the kernel and the system level, all the way up to an application framework for building new apps and a suite of apps. It has two goals, that platform. One is to deliver to end users, which you guys would be with a phone, a mobile experience that's cutting edge and top notch. But the second side of that is to deliver a software solution that allows you to build new apps, to extend the platform, and to innovate in the mobile space. Android's also an alliance called the Open Handset Alliance, the OHA, which is a group of industry players who are committed to openness in this space. Why now? Why are we doing this today? Why is Google doing this at all? There are, by most estimates, a couple 100 million PCs that have people sitting in front of them. There's a little more than that, about 1 billion people who are online at some point, about 1 billion internet users around the world. There's 1.5 billion televisions, and there's just under 3 billion, most estimates put it at 2.8 billion cell phones in the world. So clearly there's this huge market for cell phones, but there is no innovation in that space compared to, say, the web. You can look at the amount of money flowing into web startups versus mobile startups, or if you and I wanted to sit down and make some neat hack on a phone, there's just really no way to do it. Or if we did do it, it would involve reverse engineering a platform, or we couldn't distribute it in any way that was open. There's controls and regulations, and it's just a very, very closed industry. So the point of Android is to open it up. Open it up for users, open it up for developers, and even open it up for the industry as a whole, whether they want to or not. The Android platform, it's got several components. At the base is a Linux 2.6 kernel. It's got a custom graphics and windowing subsystem, no X11. It's got a custom virtual machine named Dalvik. We'll talk about that. And then all the way up the stack, it's got a set of APIs and a framework for building apps. So I want to talk a little bit about its architecture. Any architecture diagram would have lots of little boxes. This one's no different. At the very lowest level, we have the Linux kernel, which provides our driver model. It provides some of our core system functionality, which at its base is the POSIX API. And it provides things like our security model, our process model, all the things we've come to know. Why Linux? Well, first off, everyone working on this project is familiar with Linux. We know Linux. We love Linux. It's got a proven driver model. This is really annoying me. All right. It's got a proven driver model. We know how to write drivers for it. There's drivers for a lot of hardware out there, and if there's new hardware coming out, we can easily write new drivers. We're not making anyone learn new things, reinvent the wheel. It's also been ported to a large number of architectures, and it wouldn't be hard to port it to new ones. It's portable. And then finally, it's secure. It's proven. We know it works. On top of that is our system-level libraries. As any Unix system, the core of it is your C library, but we also have WebKit, which provides our HTML rendering, SQLite, which is our database solution, OpenSSL providing cryptography support, FreeType does our font rendering, and then we have a media framework, which is provided by a company called Packet Video, who is a member of the Open Handset Alliance. The media framework contains your MP3 codecs, your H.264 codecs, MPEG-4 codecs, so on and so forth, all of which, I'll add, will be open sourced. And then on the far left, you have the graphics and rendering pipeline, which we'll talk about. And then you have the runtime. This is our virtual environment where apps run. It's based around the Dalvik virtual machine, which we'll talk about, and then the core libraries on top of that. Android runs applications that are written in the Java programming language, but not Java. They are what we call DEX bytecode, and they run in the Dalvik VM instead of the JVM. Top of all this, sitting on top of both the system side and the runtime, is the application framework. Provides this, junk. This is our set of APIs that you as app developers would write to. The interesting thing here that I want to touch on are two of these guys, the location manager and the XMPP service. The location manager is a set of APIs around geolocational services. At its core would be a very simple API for getting your current location in some standard format, like longitude and latitude. So your app could say, "Where am I?" and get back a response. The information is hardware independent. So at the lower levels of the system, we answer that to the best of the system's ability. If it has a GPS and the user has enabled the GPS, there's basically a security mechanism so that the user has to opt in, enable the GPS. If it's been enabled, we could return the GPS results. If GPS is turned off or you're indoors, we fall back to the next best thing, which might be cell ID, triangulating from cell phone towers, looking at Wi-Fi networks that have some sort of geolocation, either a database on the device or if the Wi-Fi devices themselves that someday provide geolocational services. And we tie that all together and then push back the best result we can to the app. But it goes further. Applications can register callbacks through this mechanism to say, "Hey, tell me when I'm moving," or "Tell me when I'm at this location," or "Wake me up when this other event happens related to location." Say, "Wake me up when my friend Paul is within 5 miles of me," things like that. So it's a pretty rich, pretty powerful set of APIs for really making apps on the mobile environment location aware. One of the early applications that have been released or mentioned, I think TechCrunch carried the story, is that there's an app that does what's open. So you open up this app, the phone opens up, zooms into a map with, say, several mile radius of where you're standing, and it shows you all the restaurants or pizza joints or top-rated bars, whatever, in your area that are currently open, and then it can rank them by Yelp score or something like that. And this is all on the fly. And Android makes it trivial to build those sorts of things, those sort of mashups between your current location and a GUI app and then going to the web and pulling down more data. The XMPP service. This is a mechanism that allows us to do point-to-point, device-to-device communication. XMPP is the protocol behind chat services, and we use ours over the Google Talk network. But what this does is it wraps in a very simple API the ability for developers to talk from one device to another. So say you wanted to write a device that did a chess game. Over XMPP, you could be playing across 2 Android phones, and you can send the move, I'm moving my rook to this spot. And very, very easy to write that sort of app built into the framework. And I think that's really neat. And in fact, one of the things that excite me the most about Android is tying this location together with device-specific, or device-to-device, peer-to-peer communication, coupled with the ability that the device is always online. So you could go online, grab some data from the web, somehow make that location aware, and then you can connect a bunch of devices together and write an app that ties this all together. And the sort of things you can do in this space with that technology, I'm really curious to see what they are. And then on top is your applications. We have Home, a standard contacts app, a web browser. We have Google Maps, a Google Talk client. We have Gmail. We have a standard mail client. All the usual stuff. So I want to dive now a little more into the lower depths of the platform. That's where I work. I work on our Linux kernel solution mostly, but also some of the other things at the system level. So I'll get into a bit of that. It's composed of 3 points, and then, of course, on top of that is the higher-level application framework, which we'll take a look at. Kernel and system level on Android, as in any Unix or Linux machine, starts with the Linux kernel. Then you have your C library, and then above that, your core or other C-based libraries that provide the crux of your system. Our Linux kernel is 2624, which is the latest, cutting edge. And you can get it in Git. We have a public Git tree today, git.android.com, where we push our changes. And we use that to track Linus's tree. Current development kernel is 2625 RC something, RC9, I think. When that's out, we'll move to that. So we're tracking the Linux kernel pretty closely, and of course Git makes that very easy. I want to talk a bit about some of the technologies we have in our Linux kernel because there are not that many of them. One of the things you see in the mobile space or the embedded space in general is players take the Linux kernel and they modify the heck out of it. I worked on the first Linux cell phone, the Motorola A240 or something. Before Google, I was at Novell and Symbian, and then before that, I was at Monta Vista. And so we had this embedded Linux system. And like most embedded Linux players, the kernel's heavily modified. Real-time modifications, new system calls, all these changes that have very little chance of going upstream. But then they use a stock user space. So you have this bastardized kernel, and then they boot the C library into X11, and they slap that on a cell phone. We took kind of an inverted approach. Our Linux kernel has minimal changes, all of which we hope to get upstream, but we've re-engineered almost all of user space because it just didn't fit our needs. So I want to focus on what the three changes we have are. One is binder IPC, which is the IPC mechanism based around BIOS's. Is there any of the Haiku guys here? No? You? It's based on the BOS's main IPC mechanism, and that's how we do process-to-process communication at the low level. At the high level, of course, it's wrapped by our Java framework. We have a logging subsystem called Logger. Why do we have that in the kernel? Two reasons. One is because of SEC regulations, managing and logging your radio output is very important. It's also very important, simply for debugging reasons. And so putting that in the kernel guarantees, it's in one of its most safest, secure places we could put it. Second reason is performance. A lot of cell phones run on ARM chips, some earlier ARM chips, particularly on Linux, because of the way the caches are set up and the tagging's done, or in some cases not done at all. You have to flush the caches whenever you context switch from one address space to another. So if we were to have a standard logging solution around a separate daemon, that wouldn't work so good. Every time you logged a message, you'd have to flush your cache. So sticking in the kernel, because Linux has a flat 32-bit or 64-bit address space, sticking in the kernel means no cache flush. And then the last is our shared memory subsystem. So there's three main ways to do shared memory on a Linux machine. There's System 5 IPC, there's POSIX IPC, and then there's more of a Linuxy way, which is you create a file, you truncate it to a given size, you unlink it, you immap it, and then you share the file descriptor with whoever you care. Either you share it across a fork or you shove it in a socket using Linux's socket credentials thingy. The downside of that is that you need a place to create that file, so you have to have a writable file system, or you incur the classic sort of unlink race when creating temp files. So what our shared memory subsystem does is provide a way to create essentially TempFS-based memory mappings without touching a file. So it's a device that returns a file descriptor without any overhead. And that provides us with a lot of performance boosts, but since we can leverage the kernel's internal shared memory stuff, it's not very large. The next level, right above the kernel, kind of sitting on the gateway between the kernel and user space, is the C library. And in our case, it's a custom libc. It's based around BSDs, so we didn't reinvent the wheel. But we made some changes. One, it's lightweight. BSD's libc is a bajillion times lighter weight than GNU libc to begin with. And we optimized it for size even more so. And then second, it's optimized for Android. So since we control the libc stack, we can make sure it's optimized for our kernel changes and it's optimized for the stack that we have sitting above it. And then we have some core libraries that provide somewhat the equivalent of GNOME's glib, low-level primitives, C-based primitives, helper functions, wrappers for some of our higher-level abstractions, wrap some of our hardware stuff. Then we have a graphics subsystem. This is also completely custom, completely internally engineered, with the exception of OpenGL, to meet what we thought were specific needs in the mobile space that just things like X11 just aren't best suited for. There's two main components. One is SGL, which is stands for Scalable Graphics Library. It's essentially a high-performance 2D primitive library, and it provides our low-level graphics level. And then the Service Manager, which is the equivalent of in X11 your compositing and your window manager. It decides which of the visible application UIs to render onto the screen with the other visible junk that may be up there. And then we do our rendering actually via OpenGL, and we expose OpenGL APIs. And if the hardware can support it, our platform's set up to do hardware accelerated 3D even on a cell phone. So, okay, we have our own VM. What does that mean and why? The VM works on Android, you write in the Java programming language, but we don't run Java bytecode. We run DEX bytecode in not the Java VM, but the Dalvik VM. We do this by converting post-compilation from .class files to .dex files using a converter that converts from the Java to the DEX bytecode. Why? Okay. It's optimized for embedded systems. The Dalvik VM is register-based, whereas Java is stack-based. We've set things up in such a way that we could share a lot of data in ways that the Java VM can't. Each Dalvik instance can share large chunks of system class libraries and Dalvik VM support from one process to another. We also have a unique kind of system where we run one VM instance per process. So whereas in some models you might have one Java VM running with 5 apps in it, each of which may have 1 to 50 threads, we run one separate Dalvik VM instance for each and every app. We can do that because we're Linux specific, and so we can rely on Linux features such as the threading model, the process model, the guarantees it provides for app isolation to make running the multiple VMs as efficient as doing all that work ourselves the way the JVM might. And since we share so much, there's not a negative overhead from having to do this. All right, so that's the lower level. But how do you actually write apps? Well, like I said, you write them in the Java programming language. We convert them to DEX. They run as Dalvik. We provide a really rich framework and a complete SDK, docs, a development environment based around both Eclipse or IntelliJ, or VI if you're like me. We provide an emulator that runs native code based on QEMU. So you could test today in the SDK, but also once everything's released, you could test your code on an emulator without needing a device. So there are 4 main building blocks to writing applications. And these building blocks enable, I have the word efficient up there. They make it very easy to write efficient mobile apps. And that's because from the ground up, we've designed this platform to be mobile focused. We've optimized things for size. The UI primitives take into account the fact that cell phones have limited space. We really designed this thing from the ground up to be for cell phones. And we had this luxury because we set out from the beginning to write something new. Okay, so the building blocks, there's 4 of them. The first is the activity, which is a class that you extend to implement in your UI. It's generally one screen in your UI. But it's basically the concept of a document or a window in other rendering or UI toolkits. An intent receiver. This is a way to respond to events. So using XML, you can set up callbacks and say, I'm interested in these events, such as I'm interested when the data connection comes or goes, or I'm interested when the GPS tells me I'm in this location, or I'm interested in when new mail arrives or a phone call arrives, or all these different things that you can set up events that you can respond to, and the system will put you to sleep and wake you up or even run you if needed when these events occur. Service. A service is a background task, generally not connected to a UI. Probably the best example I could give would be MP3 player. So when you first decide to pick a certain playlist and play a song, clearly there's a UI, and so there's an activity, but then you may navigate away from that activity. You might be on Google Maps, or you might be on the phone, I guess in which case you probably want the music muted. You might be in the web browser, maybe the screen's off and the device is in your pocket, but you still want the music playing. So while there might be an activity to control that service, the actual music playing is a service. And last is a content provider. This is interesting. Content providers are basically ways to share data in standard ways. And they have two main benefits. And I can give you an example which shows both of those benefits. On Android, the address book is a content provider. So what does that mean? The address book is implemented in a way that it's standardized so that any application that wants to get at information in the address book goes through the same mechanism, so we have a unified address book. If you're sending an email in Gmail, you look up the email in the same address book that you used to look up a phone number to make a phone call, and the same address book that contains addresses for mapping in Google Maps. And so all these apps using a same standardized API can plug into the same address book. All right, that's one half of it. The other half is you can now, as a developer, come in and replace the database, the unified address book, with your own. Say you want your address book to live on the web, or to, using the XMPP model we talked about, be distributed among you and all your friends, or whatever other crazy hack you come up with. Well, you just re-implement the address book according to the content provider API, and then all these apps, Gmail, the dialer, Google Maps that we talked about before, can pull from that new database, and it just plugs right in. And so it's pretty powerful. On both ends, you get extensibility. All right, what does open mean? The goal of Android is to be open to developers, open to industry, and open to users. Open to industry. That's probably the least thing we care about in this room. The goal is that handset manufacturers and telecom carriers can take Android, modify it, and ship it. They can do whatever they want with it. The idea is real companies will be shipping Android-based solutions. Open to developers. That's what gets me excited. So the previous one was really talking about how people could make cell phones based around Android. But here we're talking about how those of us in this room and other hackers could make applications that they can then ship to the whole universe of Android users. The neat thing about Android, which is different than any other cell phone app distribution model I've seen yet, is that you don't need permission to ship an application. Let me make that clear. There will be no requirement from Google or any of the handset providers to require you to only install or use certain applications. Thank you. No one will be forced to use a central repository for getting apps. And application bundles for security reasons need to be signed, thankfully, but you can self-sign your app. There's no certification and no registration process. Excuse me? Yeah. So yes, it's open so much so to the detriment of us. Maybe it's so open that the next cell phone that ships, they'll disable this functionality. That's definitely possible, except official Android providers that are members of the OHA, which includes Samsung, Motorola, HTC, and someone I'm forgetting, as well as telecom companies such as T-Mobile and a bunch of foreign ones I'm not familiar with, including NTT Docomo, have all agreed that all the devices they ship will follow these rules. Okay, so you can now write apps. No one can stop you from installing them. That's really cool. But are the apps crippled? Not at all. The apps can do almost pretty much anything. Because of this component framework I've been talking about, it's very easy to integrate apps that take advantage of other things in the system. So if you have an app and you want it to be able to send email or surf the web, you could take advantage of the existing email facility on the platform with one API call, send email. You fill out some information, and right from your app, you can integrate with that functionality. You could extend very easily. Say you want to keep Google Maps, the mapping app we have, but you want to add some functionality. You can write an app that just extends certain classes, and voila, you give Google Maps different behavior. And finally, you could actually take an entire subsystem of the device, like say the home screen, which is what the thing boots up to, what it is in its default state, the app selector or whatever, and you can write your own. And all you have to do is implement a certain object, which uses the intent thing we were talking about earlier, and you could have your own home screen. Nothing stops you from doing that. So here's the little architecture thing we were talking about before. You can get rid of all the apps. Install your own. That took me 3 hours. All right. Here on the left is a very old version of our Google Maps tool on Android. You could see, I don't know, this is Mountain View, California, the Googleplex. Basic app thing. We have Google Maps available for other platforms as well, so this is nothing you haven't seen. On this side is an example of taking that Google Maps technology and extending it. What this developer here has done has extended it to be not just location aware, but location aware vis-a-vis you and your friends. So there's this person, and there is where his friend Linus, represented by this lion, is. And presumably his friend Mark is somewhere not on the map. So they took the existing technology and just extended it using the existing APIs to add this neat functionality where now you could keep track of your friends. So what I'm really saying here is the platform's open on 2 levels. One, it's open simply because when we're done, it'll be completely open sourced. But 2, it's open just because the API itself allows for very, very easy use and reuse of the system. And I actually think, although we as open source developers tend to champion the former, champion the fact that it's open source, it's the fact that the system itself at an API level is so open and extendable and componentized that I think will really allow for neat innovation. All right, here's some little dorky thing about replacing and reusing components. So you have a client wants to make a request. This is how our intent system works. So Gmail here is the user wants to insert a photo into an email that he or she is sending out. So Gmail sends out an intent called, I want to pick a photo. So the system is like, oh, okay, so he wants to pick a photo. I need to find the best photo picker intent that I have available. In this case, it's the photo gallery, which is a simple tool that we ship that is a simple photo gallery of all the photos that you've taken with the device or otherwise stored on it. You flip through this device. It has a standard way of selecting a photo, and it returns it to Gmail. Gmail just then embeds it in the email, and away it sends. So, okay, let's give an example first of replacing the functionality. So, all right, you want to write your own. You could get rid of that photo picker and replace it, in this example, with a Picasa backend. Implementing the same API, instead of going to the local device's photo gallery, you can go online and grab something from Picasa, or you could grab something from Flickr, or you could do something that talks to all the Android phones in a 10-mile radius and collaborates with them over some sort of swarm P2P network and grabs their photos. I mean, whatever you want. Likewise, an example of reusing a component, say you wrote a new app, in this case a blogger app. I don't know why you do that. It then can make this pick photo call in the same way. It's a standard API, and whatever is there, whether it's Picasa or the previous photo picker, it could just grab the photos. All right, open to users. When I say users, I mean not developers. We usually call in the Linux community users, developers, same thing. I mean open to every random person who has the phone. What does this mean? Well, users don't need permission to install applications. As I said before, devices from Alliance partners will not restrict users. Users will have full control over their experience. The devices aren't locked down. They're configurable. The defaults are changeable. There's a security model where you can opt in or out of whatever you want. No one's saying you have to use Gmail on the phone. If for some odd reason you prefer POP3, we ship a POP3 client, or you could write your own. You could download someone else's. The phones are completely open. All right. Let's look at the current status and where we're going next. So it seems like, at least for me, that we announced this thing a year ago, but it was actually less than 6 months ago, November 5th. And then exactly a week later, look at that, we released the SDK. And then it wasn't until mid-December that we released kind of the final version of the preview of the SDK. That was the 1.0 final bug fix release. So it's only been a few months. And then on January 3rd, we started taking submissions to the Android Developer Challenge. What is that? Well, our goal is to help developers kind of start the innovation going. We believe this platform can do some pretty amazing things. We believe that everyone from hobbyists scratching an itch and having fun up to big companies looking to make money can find this platform a source of innovation. And to that end, we've put $5 million US, so it's a little less than when we made the first offer. $5 million US available in a contest, which don't quote me on this, I might be wrong. I think the top prize is a full $1 million, and then there's several smaller prizes, but I could be wrong. And then there's going to be a second phase of the challenge later once the devices ship, in which we'll do the same contest again, but once everyone actually has devices. It's due tomorrow. Tomorrow, at some point, if you need to submit the app to that URL, you don't need to include source, and there's a judging committee of which I'm not allowed to be a member because of... Okay. What's next? Okay. Code.google.com, which is Google's open source repository and developer tools, has a page at /Android where you can download the SDK. There's some mailing lists. I think there's an issue tracker. We have some documentation, some example code, a bunch of YouTube videos. So if you're interested in that, you've probably already been there. When are the first phones? The first phones will be shipping by the end of the second half of this year. And once the first phones ship, we will fully open source the platform. That's every component. That's from the kernel up through Dalvik, the graphics libraries, the framework, everything. Let me cut off and kind of preempt the first question. Why isn't it open sourced yet? We all want it to be open source. But there's several reasons it's not yet. One is we've been focusing on getting the first devices shipped. We want to make a big splash with the first device. And we're not ready to ship yet. And so that's what we've been concentrating on. The second reason is, we could just throw the source over the wall, and that doesn't take a whole lot of effort. But our plan with this is to build a community and to build an ecosystem. And if we do that, that takes a lot of work. And so to do this right, to actually open source this in a way that's beneficial to a long-term relationship with the community, we want to wait until we're at a point where we can concentrate on it and the code's not a big mess because I'm touching it. And then the third reason is some of this code, like the packet video technology I talked about earlier, and some of the other code that's been contributed by OHA Alliance members, they're not ready for us to open source it yet for whatever reason. So we're just not there yet. But again, second half of this year, we'll see phones, and once you see phones, everything will be open sourced. And that is it. Thank you. Okay. Questions? Okay, got my shiny questions, Mike.
Why not Cairo for the 2D graphics library?
Why not Cairo? Why not blank? There's, we could ask 50 of those questions.
I'm particularly curious about Cairo specifically.
So most of these specific technology questions were before my time, so I can't comment on the actual decision making. Google had a set of technological requirements we had in place. We evaluated all the available technology, and we decided to go with what we went with. I don't know the specific reason behind not Cairo. I mean, I think Cairo is really nice. The SGL is pretty nice too. So.
I guess this kind of goes with that is, so you talked about the chess application, and that works if you're talking mobile phone to mobile phone, but if you want to play somebody on the desktop, well, so you either have to release all this for desktop apps as well, or the application has to make his application twice, once for the desktop and once for the phone, right? So, I mean, the API set on Android is unique.
Right. Yes. And if your second, your follow-up is there plans to do a desktop version? I am not prepared to announce anything today, but it's open source, or it will be. One thing about that, though, is you don't necessarily have to have completely different apps in the sense your communication channel could be something that's open, such as the web, right? So, in fact, I think that's, if you're not talking to another device, taking advantage of web APIs is definitely the way I would write an app.
Did you think about making Android available on existing handsets rather than waiting for new ones? I mean, I've got a Nokia E50 and it sucks balls. And when Android came out, I thought, brilliant, maybe I can run it. And now I can't, and I have to wait till the end of the year for HTC to release stuff, buy a new phone. Why not make Android available on existing handsets rather than have to get all new exciting ones?
I think the idea was, if we really want to change this industry and compete with the top players, our first device needs to kick butt. And so that was the thinking. And that's our goal. But eventually, once that first device is out, I expect to see Android across a full range of devices. It's someone else at Google had a quote. There's no one Android. We want there to be hundreds or thousands. From the low-end free phone you get for renewing your contract to, at least in America, when you get phones and you renew contracts, to whatever the most expensive, awesome phone is that's available.
Hi, I've got two questions, so I'm going to be greedy. The first question is, you say you want to build a community and have this be a big, open source project. Does that mean that you intend to have, for example, community contributors and the community helping to define architectural decisions and things like that? And then the second question is there any sort of agreement with the Alliance members that if I write an application for one phone, that it really is going to work on the others? I mean, how much are they allowed to differ from one another?
Yeah. That's good. First question, yes. The plan is to have a real community. So I'm not aware. I'm not handling the community relations, so I don't have any exact details. But yeah, the idea is to do this right and have a real community, and not just a software repository somewhere. And then to answer your second question, to be an OHA member, you have to, the changes you make can't break the high level framework. So there's some level of compatibility that's required. And moreover, I don't think the handset carriers are going to want to break the framework. So, and because it lives at such a high level inside of the Dalvik VM, it's not quite the same as I change some low level thing in the kernel and the framework breaks. And the framework's going to either work or not work in most cases. Just so you guys all know, I'm not picking people. There's a dude with a mic, so get his attention. I love you all equally.
So you said that you didn't really want to just throw codes over the wall. To some extent, that's what you've done with the kernel so far. There's a public Git tree available for your kernel. And one of the things that allows is for people like me to look at your kernel and say, dude, you're doing this wrong. But unfortunately, there doesn't seem to be any way for me to tell you that, rather than just shouting about it on LiveJournal or something. So is there any way that I can give feedback about your existing public development?
Yeah. Well, first off, all the kernel changes we've been working with the ARM community. Are you talking about the ARM changes?
The whole Android's power thing just seems to be this bizarre bolted on the side extra power management framework, and it's ignoring some existing interfaces that would do the same thing.
Yeah, I think we have a goal to fix that.
Okay.
You know me, so you could have emailed me like 6 months ago.
Well, I was going to answer a question from back here. Someone has got an Android running on a Nokia N800.
I saw.
So you can actually, I think, run it on, that's not a cell phone, but...
Yes.
Okay.
But,
so then...
I've actually seen it running on on like I think the 770 and the 800, but maybe not the 810. You say the 810 as well?
I thought it was just the 810. Maybe it's just the
maybe
810,
all three. I've definitely
I
I've read and seen screenshots of it on the first two, and then I've also someone got it working on the Asus EPC and one other hardware. But I think people have even had it on phones. The hard part is the radio stack on phones is horribly complicated and almost always closed source. So getting the phone to actually be able to make phone calls with Android would require cooperation with the handset manufacturers usually. But yeah, a lot of people have it running on devices. I think it's pretty neat. I believe the license agreement for the current SDK says you can't put it on a device yet.
So my question was: are you really going to open source like the applications as well as everything else beneath those, like Gmail? You're gonna?
I was wondering that before I had this talk because I thought someone was going to ask me that. In general, yeah, all the apps are going to be open source. Whether literally every single app, I'm not sure. But I mean, as far as I know, just at least all the core apps are going to be open source. I think when this comes out, people aren't going to be like, aha, but they didn't open source this key thing. I mean, everything's going to be open. But if Gmail or some random thing's not, I can't say.
Are you guys going to have an open source radio stack as well? Because you just mentioned that's actually a big problem in building some devices.
At the moment, I don't think we've gotten to that stage yet, and I don't know where we are with individual handset manufacturers. So I don't know. That would be great, but I think definitely when the phones ship, the one thing that might not be open source on some of them will be the radio stack.
You said you're going to open source the packet media stack with the codecs. Is that going to include any kind of patent license for the patented codecs for hobbyists, or manufacturers have to pay for that?
Yeah, I don't know the answer to that either. Okay. Sorry. Or I refer you to the OHA. And not because there's some secret reason, I really don't. I don't know.
First of all, thanks for this platform, but I got to ask, I haven't really got the answer yet or figured out. What's in it for Google? What are you guys getting out of this?
So I don't know the number, but there's billions of dollars flowing into web-based startups every year, right around this town. And yeah, it's such a small area compared to mobile. And so I think in one sense, Google wants to innovate in mobile like ourselves the way we can on the web. And we can't, if someone else isn't going to provide an open platform, then okay, we will. And the other side is, the more mobile users, the more web users, the more web users, the more Google web traffic. And then the third reason is, it might seem silly, but the "don't be evil" thing is serious, and this is somewhere where we really think we can do great good. So, thank you.
Will it be possible to create native applications that target the platform, or are we stuck with the Dalvik VM?
All right, that's a good question. So this question is, can you write native apps in, say, C or C++? At the official application level, no. It's whatever is supported by Dalvik. So does that mean in the future Dalvik won't be able to run things other than stuff compiled from the Java programming language? No. I'm sure someday, maybe even officially supported from us, there's no reason we couldn't also run, say, Python.
So you could make the other compilers that target the VM?
Yes.
Is it possible for third parties to do that? Is it documented to that extent?
Currently, no. But my second half of the answer was, okay, so on the official side, applications that are distributed and signed, which we call them APKs, that's the bundle we ship them in, have to be Dalvik apps. But the platform's open, so nothing stops you from actually taking the platform and writing whatever you want in C on top of it. So we're kind of distinguishing between like this official channel for developers and, at the end of the day, you can do whatever you want, which includes writing C or C+ apps.
A big part of this solution for users when their phones first get out there is actually getting the data onto the phone. Now, that's fine if you do a web, like across the web or something, but public access to your private data like that's not so common. So how are we going to get our contacts, all our photos, our music, all that data onto the phone? Because we're going to want to. Is there going to be support for some type of open desktop integration software that will allow us to do that? I mean, Google Calendar and the lack of the integration tools that aren't open source are a good indication of that, you know.
So you're asking how are you going to be able to get whatever data ends up on the phone off the phone? Onto the phone, okay. So, right, integration points that have a corresponding Google service, such as Google Calendar, chat, mail, all of that will be synced instantaneous. There's some of those videos I talked about. We've done demos where you make an appointment on your computer and it instantaneously shows up on the phone. You add someone to your address book on the phone, it instantaneously shows up in your Gmail address book. So those sort of points are already integrated. Other ways like the photos you take, maybe those will be integrated with Picasa. But as a general way to slurp off data, that sounds like an app for someone to write. But in general, the neat thing about this phone to add is it lives in the cloud. So I break the phone 5 times a day when I brick it because I make a bad kernel, the emulator or a test phone or whatever, and you just reboot and log in, and the phone kind of lives in the cloud. So there's a lot of benefit to the data isn't necessarily on the phone, or it doesn't have to be, or you could have ways to easily push it.
Is the Android toolkit going to be restricted to one or a few types of cell phone networks, or is it going to be able to be used on all networks?
Is Android going to be restricted on what cell phone networks it works on?
Yeah, for example, can it be used on CDMA and GSM?
Oh, okay.
And so forth?
So that's what actual protocol it speaks is up to the radio stack, and we have a pretty extensible, easy-to-use interface to the radio stack so that literally anything will work. So there's no reason you couldn't get Android working on any type of radio. So there's no restriction on that side. And what the first phone will ship with, you could look at who's a member of the OHA to get an idea.
Okay, thanks.
Mm-hmm.
You mentioned it briefly earlier, but since you're standardizing on the high-level APIs, does that mean, for instance, if a cell phone manufacturer wants to replace WebKit with Firefox or your video framework with GSIMmer, they are able to do so as long as they stay compatible on the high-level APIs?
As long as they stay compatible, I would, that sounds like in the spirit of openness something we're okay with, but I'm not a lawyer and I haven't read, different various agreements, so I can't say for sure. But in general, yeah, that sounds like something that we'd encourage even.
What do you think about OpenMoko?
I'm not really familiar with it, to be honest. Sorry, it's a cop-out answer. It's very orange.
You mentioned that the manufacturers won't lock it down, but can carriers lock it down before they sell it to customers? Because right now they're already starting to complain about support costs with Windows Mobile and Palm and all this other stuff that's out there. And also, can programs that were installed on a phone, can the keys be revoked and deactivated remotely?
So are you asking something beyond what? So to be an OHA member, you have to agree to not lock down the phone in certain ways.
That's a manufacturer. That's not a carrier.
No, from the carrier side as well.
The carrier side. Okay.
Yes. And again, I'm not a lawyer and I'm not privy to what those actual agreements are, but the general spirit of them is to be a member of OHA, you have to agree to some level of openness.
So carriers can't revoke programs that turned out to be toxic on a number of phones in their network?
I don't think so.
Okay, so they're okay. The example is a bad app gets out there, starts basically disabling customer phones. It ends up being the carrier's issue of support. Either going to show up at the store. My mom buys an Android phone and downloads a bad app.
Yeah.
It's going to show up at their store.
But the whole idea of buying phones from a cell phone, this is my own personal opinion, the whole idea of buying cell phones from the cell phone carrier, imagine if you had to go buy your Dell machine from your cable provider. It just doesn't make any sense. And there's nothing in this world worse from a reliability standpoint than Microsoft Windows, and yet the cable and DSL companies aren't going broke because of everyone that's plugging in Windows machines. There's the Carter rule, right? So up until 1976 or something, you could only plug, and this is in the U.S. for non-U.S. people, you couldn't plug something into the phone lines if it wasn't approved by AT&T, and eventually this got overturned, and like that same year, the fax machine and the modem were invented.
Okay, then the question becomes who supports the platform it's sold to the end user? Because the carriers aren't going to support it. If I buy the unit, that means I'm buying it. We're creating a new business model from the point of view of selling the physical hardware and separating it from the network.
Yeah, there will need to be, whether it's provided by Google or another party, some level of support provided. And then, but I mean, the handset manufacturers support their handsets today.
So we're going to see Android stores?
No comment. Okay? All right.
A cell phone that would triangulate my location scares the shit out of me.
Yeah.
Who would be privy to that data, that triangulated data of where I am, where I've been, how long I've been there?
Well, first off, I'd have to leave the phone.
Well, I know they would.
I mean, it would have to leave the phone. So you're saying, do we record that information and then send it off the phone?
Well, certainly, if there was an app that said, "Oh, my friend so and so is at this location," can someone opt out of that to say?
Oh yeah, that neat thing I was showing. If that was ever commercialized or part of the platform, would be completely opt-in. The applications by default have very, very, very strict security models, and the user has to opt them in to just about everything, including accessing the GPS. But I mean, if you're worried about people tracking you, the cell phone companies could do it today, right? I mean, that's how the cell phone network works. They have to know exactly where you are.
That's why I don't own a cell phone.
I don't even know why you're at this talk, man.
Because I'm curious about the technology.
All right. And it gets worse. There's a law coming out, I think, that they need even further tracking for 911 purposes. Yeah. I don't know what that is, but okay.
Okay. Any other questions? And I just wanted to make a little announcement for those people watching on videotapes. If you're interested in other DVDs along this line, visit my website, www.mediaarchives.com.
This is being videotaped?
Yeah.
Oh, God.
Oh, no. Any other questions? Well, I think, one last question.
All right, last question.
All right, you've mentioned the first phone you want to make a big splash with, and it sounds to me like you have a lot of, or perhaps Google has a lot of input into the hardware design. Is that the case, or is it being developed, separate from you guys, and you just hope it's going to be a good one?
That's a great last question, and it's going to yield a great bad last answer. We're working with various members of the OHA on the first handsets, but we have nothing to announce today. Thank you, everyone.
Ladies and gentlemen.